Hey there, I'm Chris, and today I want to talk about architecture. Specifically, let's look at the Sabergame project. I have a playlist for it if you are interested in more about it, but I want to take a look at the code in it and talk about how I architected things from a standpoint of services. So the Meadow stack has a DI container. Really, it's an IOC DI resolver. It's really lightweight, but I tend to use it a lot. And if you look at Sabergame, we really have three functional areas in the application. One is the input, the buttons on the box and the blades themselves. We also have output functionality. On the physical box, there is a LED matrix display, but for development, I also used a console display. And then we also have output in the form of audio, so beeping sounds. What I did was I took each one of these three functional areas and made an interface for it. So you can see here we've got the input service, and this has the two blades and then our 5 buttons. Our display service, simple, we were either showing some text, showing score, showing a touch left or a touch right, and then audio, either beep or mute to turn it off. So what I've done is I then implement each one of these. The display service is just using a MAC 7219 LED matrix, and it implements those. The details on that, you can take a look at the source code. Link is down in the description. This is the same thing, or the same interface, but implemented for the console. If you take a look at the input service implementation, really it looks just like the interface. Here's the interface, and there's the implementation. We've just made public properties for all of these. There's nothing magical going on here, but what I've done is I've used separation of concerns to move things to their own class types based on the functionality in the system. The beauty is when you go to put all of this together in the application, it lets you test, it lets you prototype, it lets you mock things much easier. So let's take a look at how I do it on the desktop. If you'll recall, I started out developing this on the desktop before I moved it to the microcontroller. So on the desktop, in Initialize, I create an input service, and I have all of these inputs using keyboard pins, so just the keys on my keyboard. Then I have a simple Boolean here, whether or not I'm using the console as the output. So I started with just a text console output. So I just set this to true, and it'll create a console display service. Once I had all of that working, I could then move on to the MAC 7219, create a display service for it, and then I create the game. You can see all I've done is create these 3 services. Then when I move over to the Meadow, to the microcontroller, in Initialize, same exact thing. I create an input service. Here I'm using the device pins, whereas with the desktop, I was using pins from the keyboard. And so I have those pins for our inputs. Then the display, we again just use the 7219. It's an SPI bus display, so it works for the desktop or the microcontroller. Here you'll see I've actually added an audio service, and really it's just a PWM. And then I have a communication service that's in process that will be for Bluetooth and Wi-Fi. But really, you can see that both the microcontroller, so the Meadow itself, or the desktop version, they both are a Meadow app, and in Initialize, I just create services, these 3 core features, and put them into the resolver services. So the resolver services is a static, and then we can add, and then this is the type we want to register it as. So we're creating an input service, but we're registering it as the interface. And that will be important here in a minute when we look at how we retrieve from it. The resolver services does have the ability to create services for you. So you can say, add new and give it a type, and the type, it will use that to create the instance for you if it has a default constructor. Realistically, I don't recommend doing it because it is slower. It has to use reflection to find type information and then go and create that type. If you can give it the type and create it manually, do that yourself. It may not be a huge difference in time, maybe 500 milliseconds kind of thing, but when you have a bunch of services and you stack it all up, it can add up to a slow boot for your application. Both of these versions, once they've created all of the services, they just create a new game, and then in the run, it starts the game. So let's go over and take a look at the game class and how it uses these. You can see it's extremely simple. At game construction, it goes in and it asks the resolver, give me the implementation that you have registered that is the I audio service, the I display service, and the I input service. So it extracts these by interface or registered type, and it gets back whatever is in that container. So when the game class goes to the resolver and extracts the I display service, if you're on the desktop and we have a console display service, it'll get that. But if it's the Max 7219, it will get that service instead. So it extracts by interface and then uses that interface. You can see it's stored here. We use it by interface for the entire application, so it allows you to swap out those services for testing and mocking as well as prototyping really, really easily. So in the applications init, we create and inject these, and then later on when we need those services here in the game, we extract them from the services. So we're always using this resolver services collection to insert and retrieve. The services collection only takes in singletons, so you can only have one instance of an I audio service or one instance of an I display service. It also has the capability of doing dependency injection, so it will do constructor injection or property injection if you so desire. Again, both of those injection mechanisms are slower. They require reflection in order to find type information and generate things and inject them. So if you can get away with not using injection, I suggest you do it. Or if you're running on something like a desktop or even a Raspberry Pi that has more power, you can get away with it. But if you're running on the STM32, the Meadow F7 Feather, I don't recommend using the injection itself, just the container. And that's it. Just a quick one today. Talking about how you can improve your code base, make it... And that's it for today. Really. I just wanted to talk to you about using... And so that's really it for today. I wanted to give you... And so really, that's it today. I just wanted to talk to you about the resolver services collection in Meadow and how you can use it for storing and retrieving services to help keep separation of concerns and use things that are interface-based. It will make prototyping and developing your applications much easier, much faster, much easier to debug. If you have any comments on how it works or questions on how you can improve your coding, go ahead and leave comments down below.